400 hours, one thread, 3 million light-years. The universe had a skeleton. We just photographed it. It connects every atom in your body to everything. The gravity matrix. The MUSE spectrograph stared at one patch of sky. Here at the gravity matrix we track this data. When the full publication dropped May 16th, everything changed. A thread of intergalactic hydrogen, 3 million light-years long, connecting two ancient quasar-host galaxies across the void. Light from when the universe was 2 billion years old. What the MUSE data confirmed was not a surprise. The Lambda CDM standard model had predicted this structure exactly. 50 years of theory, the universe matched the simulation. But that same week, a second discovery doubled the stakes. Cosmology, JWST's largest general observer program, had finished its survey. 0.54 square degrees, the width of 3 full moons. Within that patch, 164,000 galaxies. Lead author Hossein Hatamnia drove the Somos web analysis. His advisor Bahram Molbasher called the data truly significant. Not interesting, not promising, truly significant. A scientist chooses those words when data exceeds the framework. Cosmology traces galaxy distribution back to redshift z equals 7, when the primordial universe was 500 million years old. Filamentary structure already visible in that infant universe. The cosmic web was not built gradually. It arrived structured. That structure has a name, the infinite cosmic web. Filaments, sheets, nodes, and voids. The 4 constituents of everything. Dark matter forms the scaffolding. It traces the gravitational web. Every galaxy you have ever seen hangs from a thread, including ours. Where exactly is the Milky Way? The answer is stranger than most people realize. The cosmic web was first proposed theoretically in the 1970s. Yakov Seldovich predicted filament collapse mathematically. His pancake model, density fluctuations collapsing along one axis. The 1985 CFA redshift survey revealed the web in data. The Great Wall, 500 million light-years of interstellar structure. Then came the M-body simulations. They agreed with everything. Illustra's Tangi runs 300 million solar masses per simulation particle. The simulations predicted Cosmos web observations before JWST launched. In our assessment, the most direct Lambda CDM check ever produced. Not a statistical inference. Not a model-dependent calculation. Direct imaging. 3 independent instruments confirm the same structure, not noise. The caveat, error bars at high redshift remain substantial. JWST's Laniakea reaches 28.2 magnitudes. Hubble could not. Galaxies invisible to every previous observatory are now catalogued. The catalog, pipeline, and web animation, all publicly available. Where exactly does the Milky Way sit in this web? We are members of the local group, 54 galaxies. The local group is near the Virgo cluster node. Pull back further, Laniakea supercluster, 520 million light-years, 100,000 galaxies converging toward a single focal point. R. Brentale at Hawaii mapped this supercluster in 2014. That gravitational focal point has a name, the Great Attractor. We are falling toward it at 630 kilometers per second. The Great Attractor, a dense region inside the Shapley concentration. 2024 findings suggest the Milky Way belongs to something larger. In our assessment, the most unsettling address in cosmology. Not as a cluster center. We are between the threads. That position in a quiet suburb may explain life here. Cluster centers, extreme radiation, galaxy mergers, total chaos. Voids, too few heavy elements. Stars, too metal poor. Now the Oxford discovery, it changes what filaments are. a filament 5.5 million light-years across, 14 galaxies rotating as a single entity at 110 kilometers per second, published in monthly notices of the Royal Astronomical Society, peer-reviewed, a question that kept the Oxford team up at night. Where did the rotation come from? This is the anomaly. The implication: cosmic web filaments carry angular momentum. Galaxies spin and every spiral may be inherited. The Milky Way rotates. Was that inherited from its filament? The data is suggestive, not conclusive. Science demands that. The Oxford filament is 140 million light-years from Earth. If Thea Rubin confirms its rotation in 2027, enormous. The universe's largest structures spin and smaller structures inherit, from the cosmic web scale to the galaxy scale. If correct, the universe's largest structures determine the smallest. What else does the cosmic web encode? Particle physics. Neutrinos have mass not zero, and the web knows. Cosmic web analysis. Neutrino mass bounds 80 times tighter. The universe is a primordial signal detector at cosmic scale. The cosmic web traces dark matter halos in visible mass. Dark matter halos form first, then baryonic gas falls inward. Gas channels down cosmic highways, stars ignited intersections. Filaments are not static, they flow through space-time rotating. The voids are vast, but they are not truly empty. Void galaxies, isolated for billions of years, undergoing independent evolution. Comparing void galaxies to filament galaxies, two different evolutionary tracks. The filament determines the galaxy's chemical history and complexity. Chemical history determines whether rocky planets and life can form. Every atom heavier than hydrogen traces back to filament gas. Carbon in your DNA, iron in your blood, all cosmic. Each was forged in a star fed by a filament. The cosmic web built not just galaxies, it built you. That is not poetry, that is the May 2026 record. The filament observations also expose a critical limitation. Filaments hold half of all baryonic mass, yet invisible. The MUSE filament was bright because quasar galaxies illuminated it. Without that illumination, invisible to every instrument we have. The cosmic web around us is mostly dark, undetected. We swim in an invisible architecture no telescope can map. Between what we see and what exists, physics gets interesting. Here is where three discoveries converge and get strange. Cosmos Web showed the web exists from ZS7 to today. VLT MUSE showed filaments can be directly imaged, not inferred. And Oxford showed filaments rotate, imprinting angular momentum. The universe is not objects, it is one connected system. Every galaxy cluster, every spiral arm coordinated. Illustris DNG predicted all of this before any of it. That match theory to observation is extraordinarily rare. The standard model still has unresolved tensions. This changes nothing. Height naught equals 67 or 73. Both cannot be right. The cosmic web structure may eventually resolve the tension. Filament statistics. A new distance-independent Hubble measurement technique, proposed by several groups, not yet validated, but promising. And then, what the MUSE filament revealed about gas physics. The filament gas temperature, approximately 10,000 Kelvin. This warm-hot intergalactic medium may hide half of all matter. The missing baryon problem, half of normal matter unaccounted. The VLT MUSE's team traced the filament galaxy gas boundary directly. That boundary, resolved for the first time as a landmark. The ESO MUSE team spent hundreds of hours staring. Hundreds. Dr. Hatamia spent years building the 164 zero galaxy analysis pipeline. When we first saw their dataset, we read the methodology. The scale of both projects is almost incomprehensible. both enabled by instruments at the absolute limit of physics. JWST results Galaxies Hubble would need months to detect. MUSE captures 90 zero spectra simultaneously from one pointing. The universe's architecture read through 90 zero spectra. Think about that. What we witness is the maturation of observational cosmology, from predictions on paper to photographs of the actual universe. The cosmic web is no longer theoretical, now a photograph. The framework moment, what to watch for next year. Ifira Rubin LSST 2027 confirms Oxford filament rotation. Angular momentum inheritance from the web becomes established physics. Non-confirmation, the Oxford result is an artifact, not physics. That is how science works. In our assessment, worth watching, Euclid maps dark energy in the cosmic web. 2026 results. Euclid will map the web at intermediate redshifts, bridging surveys. Together an unbroken census from 500 million years to now. The 13 billion year architectural record of the universe, finally complete. And then what we don't know. That makes this extraordinary. We don't know if the cosmic web has a handedness. We don't know what makes some filament nodes into clusters. We don't know the cosmic web beyond our observable sphere. That uncertainty is what makes this moment in cosmology extraordinary. Now to the metaphysical implication, and it is visceral. The Big Bang produced hydrogen and helium, almost nothing else. Every carbon atom in your cells forged in a star. Those stars formed because dark matter filaments concentrated the gas. Without the cosmic web, no concentrations, no stars. No stars, no heavy elements, no elements, no you. You are not in the universe. You are the universe. Cosmos Web mapped 164 zero galaxies, each a variation on one theme. The same dark matter filaments, the same physics, everywhere. 400 hours, one photograph, the skeleton of everything. Full breakdown pinned in the comments.